US Physics Olympiad, year 2012, F equal MA, first round. Problem 4. The particle at rest explodes into 3 particles of equal mass in the absence of external forces. 2 particles emerge at a right angle to each other with an equal speed v. What is the speed of the third particle? Solution. Here we can use momentum conservation, which is initially equal 0 and finally must be equal 0. So it means that momentum for 2 first particles is m multiplied by square root 2v, and it must be equal to momentum of a third particle in opposite direction, which is mv prime. So from here we can find that v prime equal square root 2v, which is answer B. Problem number 5. A 12 kg block moving east at 4 meters per second collides head-on with a 6 kg block that is moving west at 2 meters per second. The 2 blocks move together after the collision. What is the loss in kinetic energy in this collision? So here we can use energy expression and momentum conservation. Let's count initial energy. Initial energy equal this expression. Now let's count what is total momentum, which is conserved. Initial momentum equal m1 v1 plus m2 v2, which is equal final momentum m1 plus m2 multiplied by common speed v. From here we can find what is this final speed v. Final speed equal this expression, and now we can find what is final energy. Final energy E2 will be this one. Now we can count what is energy loss. This is the expression for energy change. Let's count it. Energy lost will be this expression. And now let's put the numbers. Here we need to emphasize that V2 is negative. This is why we put here a plus. And the answer is 72 joules, which is answer D. Problems number 6 and 7. The following information applies to questions 6 and 7. 2 cannons are arranged vertically with the lower cannon pointing upward towards the upper cannon and the upper cannon pointing downward towards the lower cannon, 200 meters above the lower cannon. Simultaneously they both fire. The muzzle velocity of the lower cannon is 25 meters per second and the muzzle velocity of the upper cannon is 55 meters per second. Question number 6. How long after the cannon's fire do the projectiles collide? And question 7. How far beneath the top cannon do the projectiles collide? Solution. First of all, we can use here a proper frame of reference. You could take a frame of reference which is moving with acceleration g downward. In this frame, the velocities of these both cannon cores are constant, and we can find what is a relative velocity. That will be 25 plus 55 meters per second, which is 80 meters per second. And to find what is total time, we need to divide full distance by this relative velocity. That will be 200 over 80, which is 2.5 seconds. That's answer B, correct one. Next question is number 7. How far beneath the top cannon do the projectiles collide? Solution. So using this equation for total height, we can count it after putting numbers. That will be around 170 meters, which is answer E.